Alright, so in this lesson we will solve for angle measures. So this time, instead of side lengths, we are going to find angle measures of right triangles, and we are going to once again use the trig, they call them trig, trigonometric relationships, or trigonometric, we'll also call them ratios. Okay, so normally I would go like quickly through this first page with you if you were in person, but like you can look back at the other video. So I'm just going to explain what we talked about yesterday real quick, or just briefly go over it. So remember that we have these thing called trig functions, trigonometric functions, and so or ratios, and we can, well, I use the sum old horse. I'm going to write that. So sum old horse caught a horse taking oats away. Some people just say SOHCAHTOA, but that means that sine is opposite over hypotenuse, and it means that cosine caught a horse, so is adjacent over hypotenuse. Oops. Over hypotenuse. Is adjacent over hypotenuse. And then we finally have tangent. Tangent, which is opposite over adjacent. Okay, and then we'll use these, but remember they depend on which angle we're talking about. So if we're talking about angle A, then I guess we can say that across would be the opposite side, and we know for sure that this is the hypotenuse. It's the longest side, just right across the right angle, and then that makes this one just the adjacent angle, right? I don't know why that one's capital and the rest aren't. It doesn't really matter. But if we talk about angle B, then ooh, I should have not made that one blue since that was blue. Whatever. We know that this angle is the opposite one. I mean, this side length is the opposite of it. I may have said angle bunch there, but this side right here is opposite of this angle. There we go. And this side is the hypotenuse, which would make, oh, I should change that. This is the hypotenuse, which makes this last one the adjacent one, this last side the adjacent one. Right, not difficult, not too bad. So let's go to the next page. Okay, so this time, instead of finding unknown lengths, we're going to find unknown angle measures. So I like to just label everything, as you know. So right here is the angle we're looking for. So this is opposite. That's obviously the hypotenuse across here, which means that this one is the adjacent one. I'll just put adjacent. So we can just do, which color haven't I used? Yellow. Okay, so we go sum old horse. Nope. Caught a horse. Yeah. So we're going to use cosine. But this time, well, I'll just put cos. We're going to do the cosine of this question mark. So cosine of x is cosine cot a horse, so 6 over 8. Right, so we have this. Now, the question is, like, what do we do in this case? Well, I mean, it's really not too bad, to be honest. I want you to think about this cosine as you did something to x. Remember, like, sometimes if you had x and you add 1, then you subtract 1, right? If you had x and you subtracted 1, then you add 1 to, like, undo it, right? The opposite of the inverse operation. If you had x and you multiplied by 2, then you would divide by 2. So, like, the inverse, I want you to think about this as, like, the inverse operation. So what you want to do is you want to do, like, you want to go, how do I explain this? Because I don't want to write it crazy. I just want you, we'll concentrate on this side. I don't know how to, I'm just going to show you what to do. How about that? You would just take the inverse cosine. This is like the undoing cosine of 6 over 8. I'm going to show you something after I show you this. Normally, I would do something like this. Like, you want to inverse cosine. Like, you want to inverse cosine that. And then, so that means you want to inverse cosine this. But that looks a little clunky. I'll do it on this one, actually, just to show you. But so that will get rid of, like, the cosine. So I end up with x equals. So I need to inverse cosine 6 over 8. So I need to inverse cosine. So normally you go to cosine, right? Cosine, cosine, cosine. But we need to go to inverse cosine of 6 over 8. And we get approximately 41.4. 41.4. So let me undo this. Approximately, actually, yeah. 41.4. But this time we're looking for degrees, right? So we know we can actually put degrees. Don't forget to put that. Should not be that bad today. Should be pretty easy. All right, so it wants to know, example 2, calculate the measure of angle B. So I'm going to go to angle B. Okay. And then I'm going to label, this is the side that's opposite. This is the hypotenuse. And that means that this one is the one next to it that's not. So this one's adjacent. So let's test this out. So some old horse, no, caught a horse. Nope. Taking oats away. Okay, so tangent. Tangent of this angle that we don't know. So taking opposite over adjacent. So 4 over 7. Remember that in order to undo this tangent, I need to like do this like inverse tangent. The inverse version of it. Like undoes the tangent. It's not really, it looks like an exponent. It's not an exponent. It's just, I didn't find any room for it. So that gets rid of that. And I get x is approximately inverse tan of 4 over 7. So inverse tan of 4 over 7 is approximately 29.74. So we'll put 29.7. 29.7 degrees. Not too bad, right? Like pretty simplistic, pretty easy. Let's just do one more for the heck of it, right? Okay, so right here. Okay, I want to show you something. That's why. So this is opposite. This is hypotenuse. Oh, I did hypotenuse, and I don't know. We'll put it in green. I forgot what I put it in before. And then I will do this one as adjacent. So I can't even talk. I actually have numerous possibilities. So if I do, so some old horse. So I can actually do sine of Fully bullet X right here. Actually, I'm going to make this yellow. Okay, so I can do sine of X equals, so some old horse, 68 over 85. But I could also do cosine of X is, so sum of horse cot a horse, 51 over 85. Or I can do, because it gave me all three sides, right? Let me draw that a little better. The tangents of X, taking oats away, so 68 over 51. And if I do any of these, I will get the same answer. So I'm going to just do it like this so I can show you a little better. So inverse sine of 68 over 85 equals, and then I'm going to put the inverse cosine of 51. Oh, I should put, this looks weird. Okay, 68 over 85. And I'll put approximately because it's going to give me that decimal, right? And this will be inverse cosine of 51 over 85. Is approximately. And inverse tangent of 68 over 51 is approximately. Okay, now let's try all these. Inverse sine of 68 over 85. So inverse sine of 68 over 85. Oh. 68 over 85 is approximately 53.1, we'll say. 0.1 degrees. Don't forget that. We just box that whole thing. Oops. Maybe a little nicer. Let's try inverse cosine of 51 over 85. 51 over 85. 51 over 85. See how it's the same one? Approximately 53.1. 53.1 degrees. And then 68 over 51. 68 over 51. I mean, 61. Oh, no, I forgot. 68 over 51. There we go. 68 over 51. 68 over 51. 68, 51. And see how it's the same again. 53.1. Or approximately. Approximately 53.1 degrees. That's just so that you can see that it's not going to magically change. Like, I'll explain this in a second. Like, if this x is 53.1, then no matter how you get to it, like, I mean, it has to be 53.1. Like, it has no choice but to be 53, or approximately 53.1 degrees. Like, because 53.1 degrees has to go with these side lengths. It can't be anything else. So no matter what you do, like, there's only one possibility, because if this is this long and this side is this long and this side is this long, when you put it together for a right triangle, remember this only works for right triangles, that this has to be 53.1 degrees, or approximately. So that's it. Thank you.